As most of you know, I am Donna Young, the National Science Olympiad Astronomy Event Supervisor, and this particular talk is oriented towards mostly event supervisors and state directors and concerning the JS9 image analysis software that we will be using online for the NSO 2020 competition in May at North Carolina State University. So I know that there are a lot of concerns from a lot of you on how you're going to handle JS9. So I'm going to show you the resources and talk to you about what's being developed to help you use JS9 in your competitions. So as you know, because we've been working towards this for a really long time, we have been using screenshots of JS9 in competitions for the last 2 or 3 years. And however, we actually are going to be accessing the internet this particular year, 2020 competition year. So most of you are familiar with the Chandra website where we post the webinars. This one is also going to be on the Chandra website. The PowerPoint will be posted on the National Science Olympiad website, and the transcript, of course, accompanying transcript will be posted in both locations. And this entire enterprise is supported by the NASA Universe of Learning STEM Outreach Program. And this time, as we talk about JS9, I'm just going to give you an introduction to the materials and the resources, and then I am going to turn this webinar over to Pam Perry, who is a high school teacher from Lewiston, Maine, a high school physics teacher and astronomy teacher. She is the person who actually wrote the DS9 investigations and activities that are posted on the Chandra website. And she has been working with Terry Matilsky in transferring the DS9 investigations into the new JS9 format so that the tools can be used online. Every time she has a difficulty with something that doesn't work the way it should be working, she and Terry get together and discuss what needs to be done to make that an effective tool to use. So, and she's been using DS9 in the classroom for many, many years. So she's very knowledgeable about how to use it and how teams and students can best learn the JS9 tools. So it says on the event description this year that we may be accessing a dedicated NASA website, and it's not maybe, we actually are going to do that this year. So you will see that the resources, as usual, you can either bring to the competition 1 laptop and 1 3-ring binder, or 2 3-ring binders, or 2 laptops. Now, of course, if we're going to be accessing JS9 during competition online, then it has to be done with a computer. And I'm going to show you ways that you can accommodate that or not accommodate that. And we are going to provide resources for you who have no clue as to how to get a JS9 question in there, how you can do that anyway. So I'll give you a few hints and clues about that. We have been using the screenshots. We have not yet actually done anything live, but we are going to be doing it as we go along this fall, as we put together the test for the invitationals and regionals in some of the states that we've been invited to write tests for this year. So those JS9 image analysis software tools can be used to analyze the same information that's in the event description using either maybe not those exact deep sky objects, but ones very, very similar. And of course, every single thing that we're going to be producing for you for resources will be posted on the National Science Olympiad website. They, for some reason, all the resources for astronomy are posted under Event Supervisors, so you have to go to the Event Supervisor menu, and everything we do is going to be posted there. And we're going to be posting things much earlier this year so that you can become comfortable with inserting JS9 into the competition. So as you know, I have two co-event supervisors, Tad Kamasic and Connor Todd. But do not, if you have a question about the event description, do not ask any of us directly. We're not allowed to answer those. You have to go to the class clarification menu on the Chandra website, on the NSO website, and from there, if you've got a question, ask it there. That, when you ask them a question that hasn't been submitted yet, they send the question to all three of us. We all give our answers. They put the answers together and post the answer on the clarification menu website. That way, everybody gets the same answer, and you might have a question that's already been asked and answered, so you'll know the answer already. We have a very in-depth JS9 how-to manual that's being written by Dr. Terry Matilsky, a Chandra astrophysicist, and he is the one who wrote the national JS9 question for the past 2 years. So you'll have an idea of the kinds of questions that can be asked with JS9. But he's writing a complete 3-part tutorial how-to guide for JS9. 2 parts are done. He's working on part 3, and as soon as he completes that, that is going to be posted. That will be a vital resource for your teams to use, and that will be posted on the National Science Olympiad website way before the end of the year, minimum, so you'll have that to use. So we always, as you know, we always write and supervise the MIT and the Golden Gate invitationals, and then we post those online with the answer key as soon as they're done, so everybody has the same sample test to use as a practice test, and not just those who are able to actually travel to those one or other or both of those places to take the test. And of course, MIT last year accepted, I think, 72 teams, so that's how many teams get to go to MIT, but everybody else can have that same test and answer key as soon as the competition is over. But we're going to do that even earlier this year. We're also writing 3 astronomy invitationals that are going to be posted online. They start in November and through December. There are 3 of them, as I said. And maybe not all, but 1 or maybe 2 will have a JS9 question. We're going to post those as soon as we're done with those also. So you will have those 3 as well as the MIT and the Golden Gate right away to use for practice tools. Now, we're going to do it at nationals. Obviously, we are going to hopefully states will have a JS9 question. And I know some of you have a concern about the laptop issue. So here's what we're going to do at nationals, but you do not have to do this whatsoever, depending upon how many people you have competing and what your facilities are. Remember, JS9 can be done from a laptop, so the students can have their own laptops, but there's other ways to do it. If you're completely uncomfortable with JS9, but you want to insert a JS9 question, then we are going to write a JS9 question that has an online version and a screenshot version. So, and we're going to send that to National Science Olympiad. It's going to be under sort of digital lock and key, and the only people that can access that are the state directors. So if you are running a state competition, you need a JS9 question. We're only doing this for state competitions because we don't want to take any chance of this getting out at all. You can request for your state director to contact NSO, and then you will have that whichever you want, the online version or the screenshot version for your state competition. But you have to make sure that that test then at your state competition, that you do not let that question out to be posted anywhere, or other teams would then have the advantage. So very carefully consider that possibility. Now we are going to be, what are we going to be doing? We're also going to be providing just some screenshot things. What we're doing at Nationals is this. Okay, some teams still bring, believe it or not, there are still 3 or 4 or 5 teams that bring 2 3-ring binders and do not bring a laptop to actual competition. So, in order to compensate for that, because if you're a team comfortable with 2 3-ring binders, bring your 2 3-ring binders. We know you actually do use laptops in the real world. So we are going to have 5 laptops set up in the back of the room. You know that there are 10 sessions with 10 teams in each session. So for every session with 10 teams, there are going to be 5 laptops set up at the back. So even if there happen to be, for some strange reason, 3 teams with only binders in any session, there are still plenty of laptops available for them to just go up when they do want to do that one JS9 question and then return to their seat. So yes, and if it happens to be a bad internet day, sounds like a bad hair day, but if it happens to be a bad internet day, we are going to be prepared with screenshots. But if something happens with the internet during the day, so some people have had it online, some people have had it screenshots, then we will score that in a different way, because the teams will be under not the exact same circumstance, so we may end up not scoring it if that happens. We're doing every single thing in our power to ensure that everybody has the exact same experience with the JS9 question. I would not do JS9 at the regional level. I think that's above and beyond what should be done there. I think if you do include it with your state one, that would be great. Of course, you don't have to, because the students can just learn the software, and whatever they get when they get to nationals. But if you do, that would be great. So, you can ensure everybody has their laptop, or they have to have their laptop, because I don't expect people out there to be able to provide extra laptops around, if things don't go right. So we're going to give it our best shot. As you know, it's not a simple thing to actually do this, but we've been working towards it for so long. This is our final product to actually do it live. And the reason we've been working so hard towards trying to get this in a national competition is this. We see a lot of the events are labs, you're building things, you're constructing things, you're bringing things you've made. It's very application oriented. And science isn't science, without the application part. That's where you actually learn the science, when you're applying it to something. So the only application you can do with astronomy or astrophysics is image analysis software. Because every single thing we do, every piece of knowledge, every discovery, is all because we analyze light coming in from deep sky objects. So that's what the scientists do. That's their tool, image analysis software. So we want the teams, the students, to have that exact same experience with science that astrophysicists and astronomers do, using the actual tools to analyze the data and answer a question. Bear in mind that if you want to just say, oh, I just don't want to bother with this JS9 thing, then leave it out. Don't do it. It's one question out of 85. It's not going to make or break probably anybody's basic score. So we may crash in flames, but we will crash brilliantly, I assure you. So again, if you have any major concerns about the event description, then you can use the clarification menu. I'm hoping with all the webinars that we're producing, we will answer your questions about how to deal with JS9 in the classroom. So now I am going to turn this webinar over to Pam Perry, and she will talk to you about how you use those tools to answer the questions that she has now reformatted from DS9 to JS9. Thank you.
So as Donna mentioned, my name is Pam Perry. I'm a high school physics and astronomy teacher from Lewiston, Maine, and I'm going to talk about some activities that help see how JS9 can be used to analyze astronomy data. So from listening to her introduction, it seems like you are familiar with DS9, so you have kind of an idea of what JS9 would do. The big difference is that JS9 is web-based, so you don't need to download any software to your computer. It runs on Macs, it runs on Windows. I mean, I can use it on my smartphone, which is really cool because I did that at a faculty meeting one day when I was bored. I was playing with the pretty pictures. So it brings image display and analysis of FITS files directly to your laptop, and it's web-based. Students maybe don't quite understand sometimes that FITS files are not image files in the way that you would think of a JPEG or a PNG type image file. That FITS files actually include arrays and tables of data, so there are a lot of numbers involved with a FITS file. And this kind of puts the tools of astrophysicists into the hands of students. So my students find JS9 really easy to use. Kids are pretty computer savvy, are used to using things with drop-down menus. There are several drop-down menus on the slide at the moment. In the bottom right-hand corner, there are some images of the Supernova Remnant Cassiopeia A in different color maps. So you can change the color map the way that the data is colored. You can use zoom to zoom in or out to examine specific areas. You can change contrast and bias to bring out certain features. So there's lots of ways to manipulate the way that the image works. And then there's also analysis tools like energy spectra and light curves. The idea behind these 4 activities is that each activity presents a question, and the activities are self-contained, so students do not have to have ever used JS9 software before. They're going to have step-by-step instructions on how to conduct the analysis. So each one, first of all, gives them a question to investigate, and then it also introduces different analysis tools. So we have one where we're filtering out different information and producing 3-color composites to show different energies. We have another one where we are looking at energy spectra and trying to identify the elements in supernova remnants to classify them as type 1 or type 2. And we have one that uses light curves and figuring out the period of light that varies in brightness to determine if an object might be a white dwarf or a neutron star. And then also one where you're looking at X-ray data and optical data side by side to try to figure out what might be the source of ultra and hyperluminous X-ray sources. One thing I realized my students didn't understand was what a false color image was. I mean, you're used to taking a picture with your camera phone or whatever, and obviously you're taking a picture and you can see things in the visible light range. And students when they look at an image, don't understand that a lot of the data that they're looking at was taken in bands of the electromagnetic spectrum outside the visible range. And that those images are false color images. It's kind of like how are we going to color the data by number to bring out different features? So that's an important thing to let them know. In the image at the bottom, you can see down at the bottom of the picture, there is a band that shows, this is on pixel intensity. So each pixel has a different number. You can see the pixel table there. Down at the bottom is a color band, and you can see which parts of it are colored black, which pixel intensities are colored orange and yellow, and so on. So it's kind of a color by number thing. So the first activity, the image that you just saw, was colored by pixel intensity. And the first activity is to have students make a 3-color composite like they might see on the Chandra website, where the colors represent the energy of the X-ray photon rather than the intensity at that particular point. So in JS9, under the analysis menu, you can use an event filter, and if your goal is to filter out just the photons that are within a certain energy range, we picked 600 to 1650 for the lower end of the energies for X-rays, called soft X-rays, and used the red color map for that one. You can see these at the bottom of the screen. And then similarly, we picked a range for the mid-range X-rays and then the high-energy X-rays, and colored them green and blue respectively. And then the cool thing is that you can then layer those 3 images one on top of each other and produce the composite image that you see at the end. This can also be exported as a JPEG if you want to take that image into, say, Photoshop and pretty it up for a presentation or whatever after that. The second activity is looking at the X-ray energy spectrum of supernova remnants and seeing if you can tell a type 1A from a type 2 supernova. So a type 1A would be the thermonuclear destruction of a white dwarf, and a type 2 would be the core collapse of a massive star. So in JS9, you have the ability in JS9 to import a lot of different FITS files. So first you would bring the FITS file in, where we're looking at 2 representative supernova remnants. So first you bring the FITS file in, and then draw a region around the supernova remnant, which you can see in green on the slide. Keep pointing this way because I have to look at my slides. Go under analysis and energy spectrum, and it will produce the graph that you see. And the graph on the x-axis is energy in electron volts, and then on the y-axis is counts. Each one of those little peaks that you see on the graph is an emission line that corresponds to a specific element. We've put together kind of a little condensed table of elements and energies to get more significant figures, to be able to figure out what element is. You can zoom in on a peak, and you can see that the peak there is in the range that silicon would be. And I have silicon, a red box around silicon on the little chart.